Hey everyone, it's Jim
and Charles
from Melatonin Amps. And in this first episode of the build series for the Universal 6or12SN7 control preamp, we're going to talk about all of the changes that bring the design up to the 4th generation. It's just amazing. When I designed this years ago for my own home system, it was one of the first of the kits. One of the first of the designs that I had come up with for myself that actually became kits, and it's turned out to be one of the most popular kits we ever designed.
And we never expected to be on a version 4.
Yeah. Now the changes are actually not that significant, and the basic circuit itself is identical, but we have made some improvements.
And if there is a conflict between this video and the later videos in the build series, refer back to this video for the correct method or the correct part, or follow the schematics and they will show you the right way.
Yeah, and we're going to repeat that a few times as we go. So let's just walk through quickly to show you the changes. Now the first thing you might note is that this is such an early build that it doesn't have the bottom plate. But your kit, of course, will have a bottom plate. Everything on the top of the preamp is exactly the same. Now, the first thing that you'll notice is that we've got a more modern IEC that eliminates a bunch of tricky...
extra fiddly wiring in the back,
Yeah. So, and we'll go over how that is wired up in detail in a few minutes. Also, you probably will notice that the ground return paths and the ground topology changed a little bit, and we're going to look at that in more detail as well later on.
Just on the power supply side.
Yeah. The actual power supply PCBs, the layout is identical. The only difference with the boards that you've got today is that we've updated the silk screening on them, so the labels are a little bit better laid out. When we first started designing PCBs, we would put the component name where the component went. And then what happens, of course, is when you drop the component on, you can't, if you're troubleshooting, you can't see where R1 or C1 actually is. So now Charles is, what he's done is, you can see here, I don't know if you can, yeah, you can see that. You can see he pulled the R1 formerly would be inside here. He's pulled it out of the box.
So it's just a lot easier to see where you have to check for components or test for voltages or things later on.
Yeah. Now the one change that did happen on the power supply boards is R2, which is the bleeder resistor, has been changed from a 1 watt to a 2 watt. Now, electrically, we didn't have to do that. We could probably have been a lot less than a watt, but in power supplies, they work hard. And over the years, I've learned that I like to see robust component values in hard-working parts of the circuit. And you'll see that throughout our kits. It just makes for a much safer, longer-lived build.
So we tend to go above and beyond the 2 times rating that most people recommend, just to be extra safe.
Yeah. Okay, so moving along, the grounding topology of the preamp stage, the input and output stage, is absolutely identical.
Same with the heaters. None of that has changed.
That's all identical. Everything in here, this is all done just like the build series. What did change, though, is we made upgraded PCB boards, and we've put in a second jumper, jump 2, and that's going to be the cathode bypass jump. And we'll take a look at that in detail in a couple of minutes. I think that's just about it for the walkthrough. I guess people probably will be interested to know sonically what the changes are. So why don't we grab the specification sheet and we'll be right back. Okay, so in the store there is a free download section with features and specifications and schematics, and we'll take a look at those schematics in just a minute.
Yeah, and links to all of these are going to be below the video as well, and on all the following videos.
Yeah, so what happens when you bypass the cathode for the gain stage is that you get a lot more gain and you change the sonics a little bit. And there's there's no point in really talking too much about the sonics because some audiophiles really advocate for a non-bypassed cathode resistor, and some really advocate for bypassing it. But what we do know is what happens electrically. So let's say we were putting in 1 volt RMS, which would be pretty typical. If we didn't bypass that cathode resistor, we would get out 6.8 volts RMS. So we'd have a gain of 6.8. What happens if we bypass it? Well, we almost double the gain to 13.3. So the universal preamp with the version 4 upgrade has gone from being, I would say, a modest gain preamp that sounds very good to one that is now, I would say, a medium to medium high gain preamp that sounds really good. And you have the option, so you can keep the circuit as it was originally, and a lot of the sweeps, etc., in the store all actually are from that original. So the preamp itself hasn't actually changed until we put in the jump, and then all of a sudden we get more gain, a lot more gain. Now we get slightly less linear performance, and I mean slightly. I think the biggest single deviation is in the low frequencies, and the shift was 0.4 of a dB. So we're not talking about a huge change, but you can definitely hear the difference. So I think if it was my system, I think I would probably start it off not bypassed and do a little bit of listening for a few days, and then switch it over and bypass it and see what I prefer. Mm-hmm. Personally, I like the cathode bypass for one big reason, that I find preamps sound better with more gain,
even if they're not using all of it.
Yeah, it's like having a lot of reserve power that, you know, it's just basically in the bank. Mm-hmm. Okay, so what about the actual schematics? Let's go grab them and I'll be right back. Okay, so this is the power supply schematic, and Charles has done a little bit of updating. It's basically the same, pretty much exactly the same as it was going way back to, I think, the first gen even. But he's improved the way we display things like the IEC, and you'll see these red and green dots on the actual component. So let me grab the IEC inlet, and you can see how I've dropped a green and a red dot. And of course the green is your ground, your IEC safety ground path. The red is your hot, and the unmarked one is your return. So that's all pretty straightforward, and we're going to go over that in detail in a minute. Other than that, it's pretty much the same. If you're building the low voltage region, you follow this part of the schematic here for the primary side of the transformer. And if you're in a higher voltage region, you follow this side. Everybody else builds identically from there on. It doesn't matter what voltage region you're in. And the reason why we can do this, of course, is because we have a universal transformer. And you can see over here, we were talking a few minutes ago about the bleeder resistor having gone up to 2 watts. Well, the schematic reflects that as well.
Oh, actually, another note about the power supply. We did end up switching the choke that we're using on there to a slightly different one. It doesn't change anything about how it gets installed. There's nothing different there. It's just a different choke, so don't be surprised.
Yeah, the specs are almost the same. And in fact, one of the specs, I think the resistance improves slightly. Mm-hmm. And one more thing, pay attention to the secondary winding wire colors. The manufacturer of our transformer, the R-Cores, is fabulous, and we've had a long, excellent relationship with them. But every once in a while, they're either out of the right color of wire, or they put the wrong color in by accident. The primary side wiring, they've never goofed up, so you don't need to worry about these colors here. But yellow, the pair of yellow wires and the pair of green wires, sometimes they get messed up, so just pay attention to that. Once you've identified the primary wires, then it'll be obvious you need a pair and a pair.
Yeah, and it'll say what those secondary wire colors are right on top of the transformer if there's any confusion.
Yeah. Okay, let's go and grab the actual preamp schematic. That's where all the fun begins. Okay, Charles did a major updating of this schematic, and it's much more representational of the actual build. But the circuit is essentially identical to all of the previous generations with going back to the third generation, it's identical. The big change we made is, you can see here, in the third generation we installed a jump one around the input coupling capacitor. And let's just spend a second talking about that to make sure that you understand. If you're going to jump C1, you've got to be certain that the gear that you're feeding the signal in from, whether it's a DAC, a CD player, a phono preamp, is in really good condition and that it's got a coupling cap on its output stage. What we don't want is two coupling caps in the same signal path when we don't need them. So if you've got a properly designed piece of gear feeding the signal into your preamp, you don't need C1. So you can jump it and you can get a cap right out of the circuit, which is a really great thing sonically. But if you like to roll, crazy tubes that you have no idea if they're any good, they're not tested, there's always a possibility you can end up with a dead short on grid 1, which is your input grid on this tube. And if that happens, you can actually send high voltage backwards to the previous gear. And if your previous gear doesn't have a coupling capacitor, you can blow it up. So that's why C1 is an option. So we always recommend you use properly tested, well-known, correct tubes in your actual gear. Anything else is always a crapshoot, and we do a lot of bench testing, and we've blown up a couple of pieces of gear ourselves.
Yep. For this exact issue. So just make sure that the gear is properly designed, that you're using good tubes, and if you're unsure, take that jump out, leave C1 in place, and let it protect the circuit both ways. That's
right. So when the jump is actually in, then you're bypassing, and when you've pulled the jump out, then of course there is no bypass. So the big change in the preamp circuit is the bypass on R2. This is the cathode resistor for the gain stage. And what that does is it allows the AC portion of the signal to basically go around the bias resistor here.
And that stops it from shifting your bias point and stops it from essentially having its own negative feedback built in. So you get way more gain out of it.
Yeah. So same thing. So jump 2 goes in here with the jump engaged or installed. Then you go around, and when you pull it, then your signal is all going through R2 here.
Yeah, unfortunately that does mean you have to take off the bottom plate and get in there, make it safe, and then pull the jump or put the jump in if you want to change things. It's too complex to add a switch onto the top plate like we have on our later rocket amplifier.
Yeah, I mean that's one of the big advantages to the modern line is that we can install PCB mounted components. It's still tricky finding the ones that'll fit, but it's much more doable than it is in the classic line.
We have one other major change on here from the early version 6or12SN7, and that's with the cathode follower. So we actually changed this topology to match a later version that we found sounded better and performed better, and it's been like this I think since version 2 now. So there shouldn't be any surprises there unless you're coming here from the version 1.
Yeah, which is a long time ago. So what I would suggest you do is you just do some listening tests with it in and out and see what you like. I suspect that you're probably going to want it installed in, but why don't you listen first to it in its regular configuration, and then you'll be able to tell whether you really like the improvement with the jump in. But anyways, it's your preamp, so you can approach this however you'd like. And let's go and start looking at the changes in detail. Oh, and before we leave, we're going to talk a little bit about the component placement. So we'll be back in just a second and we'll do that properly. Okay, now when you're building the 4th gen preamp, it's important that you follow the build series, but as you're building, use your schematics. Use your power supply schematic. And when you get to install a component like C2 or R2, tick off your component as you install it and make sure you check the component placement on the PCB.
And the value.
And the value.
A capacitor or a resistor or anything like that.
So let me grab the new PCB. So what that means is when you put R1 in, you should be looking, you're watching the build series so you know basically how the board gets assembled and soldered in place and the sequence of build. But you're going to look at the schematic always while you're building. You're going to say, okay, I'm starting with R1. You're going to find R1 on the board. That's right here. And that's where R1 goes. I mean, what's happened is that because the board's gotten more crowded and we had to shift around a few little things, is that some of the labels changed a little bit, their location on the board. So this, the schematic and the PCB, those are your guiding
features that you need to follow.
Yeah. So just pay attention to that. I like to go through and actually put a little tick mark beside each of the components as I put them on the board. And here's a tip. I do a lot of the professional builds in the store for customers. And so I get better and better and better at building these things quicker and quicker. And one of the things I really like to do is I really like to do one component at a time. So I'll probably build both of these PCBs at the same time. So I'd have two identical boards and I'd put both R1s in place. But I wouldn't move to R2 until I had this finished. I wouldn't even pull the R2 resistors out until I had R1 installed properly.
It's too easy to accidentally switch them.
Yeah. Okay. Well, let's just start talking about the actual changes step by step.